Problem number 1, as usual, you should first always check, hopefully you know what I'm going to say, for a GCF. Always look for a GCF. So here we have that A is 1, B is negative 19, and C is 90. These three numbers do not have a common GCF, so we're not going to be using GCF to factor this. However, since the degree is 2, so degree 2, and the leading coefficient is 1, so I'm going off of this and this, that tells me that I'll be using X method. X method is when you're looking for factors of 90 that would add up to negative 19. Okay, so factors of 90 that add up to negative 19. So that could be 3 and 30, 3 and 30, or 3 and 30 is not going to work. 45 and 2 doesn't work either. What else goes into 90? 9 and 10. Oh, well, yeah, duh, we're trying to get 19. So this would be negative 9 and negative 10. So that would be factored as B minus 9 and B minus 10. Hey, remember, B is just a variable, so if it makes you a little uncomfortable, feel free to change the B to an X. But it's just a variable. So X minus 9 and X minus 10 would work here. Okay. So I know most people call that the X method. They would write like the 90 here and the negative 19 here, or actually I might have written it upside down. I don't really know how to perform the actual X method. But the key concept is you're looking for two numbers that multiply to 90 and add to negative 19. So look at what I used to figure out what method to use here, okay? I'm only going to be doing the odd numbers, and I'm going to leave the even numbers for you to use to practice. Okay, again, number 3, there's no GCF again. So I'm going to write no GCF. Degree is 2. Okay, and the leading coefficient is 1. So we're doing X method again. In other words, two numbers that multiply to 30, but when you add them, you get 13. So that's going to be 3 and 10. But again, we're not trying to factor, we're just trying to identify the method. Okay. Here we're looking at 4, 20, and negative 96. So A is 4, B is 20, and C is negative 96. Okay. Well, does 4 go into 96? Because 4 definitely goes into 4 and 20. So the answer to that is yes. 4 goes into 96 24 times. So this is GCF method. You're going to be doing GCF, and the GCF is 4. So that's the method. Number 7. Okay, we have degree is 2 again. Sorry, leading coefficient is 6. A is 6. B is 42. C is negative 48. These three numbers do have a GCF. The GCF is 6. Therefore, that is the method that we would use for number 7, GCF. So anytime there is a GCF, you will be using GCF method. Okay, let's move on to number 9. Number 9, we have A is 6, B is negative 45, and C is 21. Okay, here we have no GCF. There's no GCF for 6, negative 45, and 21. So 6 doesn't go into 45, and 6 does not go into 21. And maybe you thought about 2. 2 doesn't go into 45 or 21 either. Maybe you thought about 3. 3. Oh, wait a minute. Good thing I went through my numbers, right? 3. The GCF here is 3. So we will be using GCF to factor this as well. Let's see what that looks like, because this may require more steps to factoring. Again, I know I said we wouldn't factor, but I mean, what's the harm in reviewing factoring, right? So if you factor out a 3, you're left with 2x squared minus 15x plus 7. Okay? And then you would still have to factor this part. And just keep bringing down the 3 as you're factoring this. But here, if you look, A is 2, B is negative 15, and C is 7. These 3 numbers definitely do not have a GCF. So with that being said, when there's no GCF and you have a trinomial here, you're going to be doing trinomial factoring. So this part right here, you would do trinomial factoring. When A is not equal to 1. Trinomial factoring when A is not equal to 1 is different than here, X method. X method is also trinomial factoring, but you only use X method when trinomial factoring when A equals 1. So because A is equal to 1, you'll be using the X method of trinomial factoring. But this trinomial factoring, as you can see, the A here is 2. So this trinomial factoring is a little bit different. You won't be using the X method. You'll actually be slip and dividing. Slip and divide. Okay, slip and divide, or grouping works as well. But since I taught you slip and divide, just stick with slip and divide. Okay. Moving on to number 11. Again, notice how I'm going to be writing down some things that I'm noticing. That way I can figure out what method to perform. Okay. So we have A is equal to 42. B is negative 35. And C is negative 216. So right away, I noticed that A and B have a GCF of 7. Okay, but that's not how GCF works, right? The GCF has to be the same for all 3. So let me just make sure that 7 can go into 216. Okay, so 7 does not go into 216. Therefore, 7 is not the GCF. So you see how that could happen? I could notice that maybe there's a GCF here, but since that GCF does not also work for this one, then we will not be using GCF method unless we can find a different. Oh, wow. Look how my eyes have deceived me. B is not negative 35. B is negative 354. Okay, so that changes things. Sorry, I don't know. Do I need glasses? Okay. Maybe it's just the black writing because everything looks like squished together. But no, B is negative 354. So now the GCF is definitely not 7 because 7 does not go into 354. Just because 7 is not the GCF. Doesn't mean that there isn't a GCF. We can explore more numbers. So something that also goes into 42 is 6. So 42 is 6 times 7. So does 6 go into 354? Yes. Does 6 go into 216? Yes. So since 6 goes into all 3 of these, then we'll be using the GCF method, and the GCF is 6. Now, similar to number 9, let's see what happens when we factor out the GCF of 6. So when I factor out 6, I'm left with 7a squared minus, how many times does 6 go into 354? 59a. And how many times does 6 go into 216? Make sure you're using a calculator because that's what I'm doing. 36. Okay. And then you could be done, but you need to check that this can't be factored any further. Okay. So this is a trinomial here, and the a value is 7. So here, our leading coefficient is 7. So we have a trinomial factoring problem, trinomial factoring again, where a is not equal to 1. So look back at problem number 9, where we just encountered trinomial factoring when a is not equal to 1. The method is going to be slip and divide. Hopefully you know how to perform all of these methods. If not, it's very easy to look up some practice problems online. Khan Academy is a great free website. Okay, number 13. Again, as usual, we're going to list out our coefficients and see if they have a GCF. 15, 21, and 6 definitely have a GCF of 3. So the method that we're going to use is GCF. Okay. Number 15. Listing out our coefficients, we have 9, 51, and 30. 9, 51, and 30 have a GCF of 3. Sorry, if you're not sure if that's the GCF, use a calculator to check. Just guess. You're doing a guess and check. Like maybe I thought the GCF was 9, so I'm gonna make sure that all the numbers can actually divide by 9, which they can't. Well, they can divide by 9, but you're not getting a whole number, right? You're gonna get a fraction or a decimal. So if 9 doesn't work, you just try different numbers. Try 5, try 4, try 3, try 2, try 1, try 7, try 8. Right? Just go through the list, right? So 3 is the GCF, so therefore the method that we're going to be using is GCF. And we're factoring out a 3. Okay. That was a lot of GCF problems so far. Hopefully we can get past GCF at some point. Let's see. 17. Okay. So for number 17, we have our coefficients 15, negative 110, 200. Now, 15 is only divisible by 5 and 3. And I know for a fact that 5 can go into all of these numbers here because 110 ends in 0. So 5 can factor into any number that ends in 0. 200 also ends in zeros. So again, 5 can factor into any number that ends in 0 or 5. 5 can go into any number that ends in 5 or 0. So the GCF here is 5. And that's the method you'll be using. Number 19. Okay, so this problem is just slightly different because of the fact that it is leading with a negative. So if this problem has a GCF, which I'm sure it does, if this problem has a GCF, you will have to factor out a negative GCF since the problem leads with a negative. So we have negative 30 to 88, and our C is negative 384. And again, notice that the A is negative. So since the A is negative, the GCF will have to be negative if there's a GCF. But there is, okay? So what numbers go into 30? For 30, we have 2, 3, 5, 6, 10, 15. Am I missing anything? I think we're good there. So of these numbers, what do I think goes into 288 and negative 384? Definitely can't be 10. Because 10 only goes into numbers that end in 0. 2 is a pretty small number, so it's possible that the GCF could be 2. But let's check other numbers instead. I'm going to choose to check 6 because 2 is such a small number. Let's check 6. Let's see. Does 288 divide by 6? Yes, I got 48. So 288 is 48 times 6. And then 384 divided by 6 is 64. Okay, so it looks like 6 is a common factor. 6 is a common factor. Is it the greatest common factor? I don't know. We do have a number greater than 6 that does go into 30, which is 15. So again, we said we know it's not 10, but let's still check 15. So 288 divided by 15 is 19.2. So that's a no. Our GCF is 6. And that's the method that we would use. So one more, I'm sorry, negative 6, right? Because since we had a leading negative, then our GCF, we will want that to be negative. Okay? So the GCF is negative 6. So let's review again, like how to use GCF. So I'm going to factor out a negative 6 because that's what I have chosen to be the GCF here. Factoring out a negative 6, that's going to give us 5n squared. Plus, well, actually that plus would change to a minus since I'm factoring out a negative. 48n. Remember, we already wrote the factors here, so I don't need to use the calculator again, right? Because I kind of already wrote how to break down the number using 6. And then this minus sign is going to change to a plus sign because I factored out a negative GCF. So this is plus 64. Okay? So that's how you factor using GCF. Now, can this part be factored? Because if it can, you have to keep going. So since I didn't show you how to continue doing slip and divide from this step, I'll go ahead and do that now. So once you get here, you can see that the leading coefficient is 5 and the degree is 2. So the leading coefficient is not 1. A is not 1. Therefore, we will be doing slip and divide. So I'm going to slip the 5 here to the 64. Okay, that gives me n squared minus 48n plus 5 times 64 is 320. Okay, the negative 6 still has to come down. The GCF. And then from here, hopefully you can figure out what to do next. Look at what you're dealing with, right? You have the leading coefficient is now, leading coefficient here is 1 n squared. And the degree is still 2. So, when the degree is 2 and the leading coefficient is 1, what method would you use? Hopefully you are saying X method or trinomial factoring when A equals 1. Which means we are going to be looking for two numbers that multiply to 320, but when you add them, you will get negative 48. So let's see. What multiplies to 320 that adds to negative 48? If anything, right? Because if we can't find any numbers, if there are no numbers that exist that multiply to 320 and add to negative 48, then we'll be writing prime as our answer. Okay? If there are no numbers that exist. So 320, well, 320 reminds me of 32. 320 reminds me of 32. So I would break down 32 as 16 times 2. 16 and 2. Or how else can we break down 32? 8 and 4. I did 2, 4, 6 does not go into 32. 32. I think that's the end of our list. 6, 2, 3, 4, 3. Yeah, that is the end of this. Okay. So any of these numbers possibly could make negative 48. Well, if we have a negative, since the middle is negative, I know that both of the factors have to be negative. And hopefully you know that as well, right? These should both be negative in order to get a negative 48. So we have 320. We're trying to get negative 48. So could we do 16 and 20 maybe? All right, because it's 320. So I want to give something here a 0. 16 and 20, or maybe 160 and 2. Nah, that's not going to work. What about 80 and 4? No. What about 40 and 8? Yeah, that's definitely it, right? We're trying to get 48. So this is the correct group that we're going with. So we're doing n minus 40 and n minus 8. Okay, so 40 times 8 is 320, and negative 40 minus 8 is negative 48. Great. So now that we found the two numbers that we're using, the last step of slip and divide is to now divide by the number that was slipped in the beginning. So we are dividing by 5 here, because that's the number that we slipped to the end in the beginning. So it comes back again. Okay? All right, so we have negative 6 as our GCF, and n minus 40 divided by 5 is going to be 8. And then here, 8 divided by 5, that does not divide. So we're going to slip the 5 to the front. So 5n minus 8. So you're able to write the denominator in the front if that does not divide evenly. And that is the final answer. So this is how to slip and divide. I've showed you many times before, but, you know, it doesn't hurt to see it again. Okay? So this was a pretty long problem. So just keep in mind the method that we are going with is GCF, because first we had to factor out the negative 6 from the entire problem. So you could say GCF. GCF is the method, but after you do GCF, you still have to slip and divide. So you could say it takes 2 methods to solve this. Okay, to factor this. All right, number 21. Hopefully, we are done with GCF. Okay, so we have A is 20, B is 195, and C is 280. The degree is 2. The degree is 2, so this is a quadratic. That's why I'm able to write A, B, and C, because it's quadratic. I don't know if I clarified that in the beginning, so I apologize if I didn't, but the reason why I can write what A, B, and C are in the problem is because it is quadratic. Like if this was degree 3 or degree 4, you would not call these coefficients A, B, and C. Okay? A, B, and C are strictly for quadratics. Because we express quadratics in the standard form, ax squared plus bx plus c. Okay? All right, so 20, 195, and 280, do they have a GCF? First thing I notice is that all of these numbers end in either a 0 or a 5. So since everything ends in 0 or 5, I can tell you that the GCF here is 5. Well, they have a common factor of 5. Is there a GCF higher than 5? No. No. Because the only other number that goes into 20, so going in, factors of 20 are 2, 4, 5, and 10. And so since 10 doesn't go into 195, because 10 only goes in numbers that end in 0. Or let me not say goes in, but 10 is only a factor of numbers that end in 0. So since 195 ends in 5, 10 does not go into this number. So that means the GCF is 5. The greatest number that's going to go into all three is 5, since 10 doesn't work. Okay, so that's the method you're going to use. So GCF, again. We got to take a break from GCFs. Let's check here. Nope, GCF again. This is GCF method. This is going to be, GCF is 2. Moving on to number 25, 12, 111, and 27. I don't believe that these three numbers have a GCF. Let's check. What goes into 12? 2, 3, 4, 6, and 12. Yeah. Do any of those numbers go into 111? No. 111 divided by 6? No. Okay. Finally. So none of these numbers are factors of 111. So no GCF. Degree is 2. And you have no GCF. This is trinomial factoring. When A is not equal to 1. So in other words, slip and divide. Okay. All right. Moving on. Again, always check for a GCF. So for 7, we only have 1 and 7. Because 7 is a prime number. 7 does not go into 2. Well, we don't list 1 as a factor, actually. So just 7. 7 does not go into 2. 7 does not go into 12. So no GCF. And we have 4 terms. 1, 2, 3, 4. So this method is grouping. No GCF and 4 terms. Grouping. Number 29. Again, we have 1, 2, 3, 4 terms. Do they have a GCF? 4, 8, 7. Well, here we go with 7 again. So 7 does not go into 4 or 8. So no GCF. 4 terms. Grouping. Okay, we have 4 terms again. Let's make sure that there is or isn't a GCF. I'm going to look at the smallest number here. So that's going to be 30. What goes into 30? We have 2, 3, 5, 6, 10, and 15. Are any of those numbers factors of 36, 16? So 15 does not go into 36. 10 does not go into 36 either, or 216. Just taking some like numbers off of our list here. 5 is not a factor of 216 or 36. So where 5 goes only into numbers that end in 0 or 5. 10 only goes into numbers that ends in 0. So that's why I also crossed that one off. Okay, so we have 2, 3, and 6. Looks like the highest one here is 6. So let's make sure 6 goes into all of the rest of the numbers. So 6 definitely goes into 180 because 6 goes into 18. So 18 is 3 times 6. So that means 180 is 30 times 6. Okay. Let's see if 216 divides by 6. Yes, 216 is 36 times 6. And then, of course, we know 36 is 6 times 6 because that's a perfect square. So the GCF here is 6, so this method is GCF. So you would factor out a 6, okay? But even when you factor out a 6, you still have 4 terms after that. So after you factor out the 6, you're also going to be doing grouping next. So first factor out 6, then grouping because 4 terms still. Will still be 4 terms left. Okay? Okay. You know what? Let's go ahead and do number 31. Let's finish 31, right? Let's go ahead and factor out a 6 and then do our grouping. So factoring out a 6 from problem number 31, we're left with 30p to the third minus 5p squared plus 36p minus 6. Okay? There we go. We factored out our GCF. Now we are going to factor these 4 terms, and you would factor 4 terms by grouping. So I'm grouping together the first 2, and then here's the second 2 terms. Okay. So in the first set of parentheses, of course, we're still going to bring this 6 down. In the first set of parentheses, 30p cubed minus 5p squared. The GCF here is 5p squared. So remember, the 6 is going to keep coming down. So 5p squared is the GCF here. And then that leaves you with 6p minus 1. So if you don't know what to write as the leftover part, so like when you take out the GCF from here, what are you supposed to write here? You're trying to imagine if I were to multiply this back, right? Distribute the 5p squared, I should get this. So 5p squared times 6p is 30p cubed. And 5p squared times negative 1 is negative 5p squared. Or you can say, once I know that the GCF here is 5p squared, this is the GCF, then I can divide this by 5p squared, the GCF, and you'll get 6p. And then divide this by 5p squared, which is the GCF, and you'll get 1. Whatever works for you. Okay, in this group, the GCF is 6. Again, you can imagine dividing. Let's do 36p divided by 6. That's 6p. And then 6 divided by 6 is 1. So look at that. You can see that we have a set of twins. 6p minus 1 is the twin. So we're going to put the GCFs together. 5p squared plus 6. And then our twin is 6p minus 1. Okay? I know I say twin often, but this is not actually called a twin. Yes, they are twins. They look exactly alike, right? But this is not actually called a twin. This is called the common factor, because it's the factor that both of the GCFs have in common. All right, anyway, this is your final answer, so this is done. Okay. All right, last we have number 33. going to my smallest number, which is 112, to see if this polynomial has a GCF. So what divides into 112? You have 2. Does 3 go into 112? Remember, you can use a calculator to assist you, especially if you're quick with typing on the calculator. 4 goes into 112. Does 6 go into 112? What about 8? 8. 112. Does 9 go in? Nope. Does 12? Nope. Okay. Divided by, what else? 11, 12, 13, 14. Does 14? Yes, that was 8. Okay. Oh, so we're good. So for 8 times 14 is 112. 4 times 28 is 112. And 2 times 56 is 112. So those are all the factors for 112. Do any of these numbers also go into, are also factors of 343 or 196? We have 196 twice, which is great because we only have to think of 2 numbers now. So which of these also factor for 196 and 243? I mean 343, sorry. I know that 190, these numbers remind me. So 343 is 7 to the 3rd power, right? 343 is 7 to the 3rd power. These are things that you guys have to start to try to recognize. So I know that 14 goes into 343 because 7 cubed is 343. So if 7 goes into 343 3 times, then 14 does. If that makes sense. But of course, you could just use your calculator if you're not sure. 14. No, 14 doesn't go out. 7 cubed. 7 cubed. It's 14. Yeah. 14 does not go into 343. Lord. What about 8? No. 196 is 14 squared. 196 is 14 squared. So 14 definitely goes to 196, but it doesn't go into 343. So 14 is not going to work. Okay. 28 does not go into 353. Does 343 divide by 56? No, it doesn't. Okay. And 343 does not divide by 8 either. 4 does not go into 343 either. Because 4 only goes into even numbers. 343 is an odd number. And of course, 2 only goes into even numbers. So because of this number here, we're able to cancel out all of the factors of 112. So none of those numbers factor into 343. So this problem has no GCF. Again, no GCF, but we do have 4 terms. So hopefully you've guessed it. This is grouping. Okay. Sorry it took that long to solve that, or not solve, but to decide on what method to use. I don't know why I thought 14 goes into 343. No. 343 is 7 to the 3rd power. 7 to the 3rd power. Okay, so 7 goes into 343, but 14 does not. Okay, all right. We are at the end of identifying factoring types. So hopefully that made sense. Go ahead and try the even problems yourself.